Hi, this is Micah Mitchell with Madison County Weather Updates. I wanted to finally get to this winter preview I've been talking about. My real job got in my way over the weekend. I don't know if all of you know, but my real job is I'm the Senior Zoning Administrator for the City of Anderson. So every third week I do on-call work, board-up work for the building commissioner. And it was a really busy week this past week, and especially this weekend. I got called out 3 times just yesterday, so I never got to this video. So I've got a migraine going on today, but I want to get this done for you. So pardon me if I get on some tangents at times, but at any rate, we'll go ahead and get into this video. And again, this is just a preview. I'm not making any kind of a prediction yet. I wouldn't want to make a prediction, one, until I've talked to Kristen, picked her brain, and 2, it's just too early to do it. It's too unpredictable anyway. Really, the only reason to do a winter forecast is just for fun, because you can have a good idea what should happen, but as winter continually shows us, what should happen and what does happen are 2 different things. So we'll probably do an actual forecast around the end of October sometime. Also want to make note of the fact that, as I'm sure many of you have seen, a couple of people have complained. We have started a website. I need to double check with Jordan. I believe it's ready to be online. The GR Level 3 radar seems to be streaming just fine, so we're just kind of creating some content to put on there so that it's not just a radar only. This video will go on the website, and we'll be adding some additional content, some things that you can look at and learn from and things like that. So that's coming. Of course, we are taking donations. There will be a donation tab on the website so that you can either do one-time donations, or you can set up for recurring donations to help support what we want to do. We will, before we ever even consider trying to get to a point where this is our only job, and I'm not even sure we could do that on a county level anyway, but there are things that we want to do to make this the best web service provider that any county has. Right now, outside of this page, for your weather, you're relegated to whatever you can get from the Indianapolis stations, or and they're not generally specific to Madison County. So we want to be able to expand that for you and continue to do this, and we want it to be awesome. We almost want to turn it into almost like a TV station, but that's going to take money we don't all have. So we'll definitely need your support, and we'll make this thing as awesome as you guys can help us make it. So that said, let's get into what you're here for. Before I get into the winter, I kind of want to talk about, I mentioned that the winter forecasting is kind of a crapshoot, and really weather in itself is kind of a crapshoot, and today kind of proved that. I'm looking up at my weather station, and here in North Anderson, I picked up 0.12 of an inch of rain today. Some places probably got a touch more, some got a little less. Definitely nowhere near the 1/4 to 1/2 inch that it looked like would happen. And this diagram that's on here is a skew T, and it's kind of like a slice out of the atmosphere, from the surface at the bottom all the way up to 9.9 miles at the top, right near the tropopause. So that's a lot of one. I don't think people realize that the weather is occurring in that large of an area. And so not only are we trying to figure out what's going on from the surface to 10 miles above here, but then we got to figure that out for, what's going on, 1,000, 2,000, sometimes, 3,000, 4,000 miles away from where we are, because it all plays together. And what looks good here, maybe, something will change halfway around the earth and set off a ripple effect that totally ruins what it looks like is going to happen here. So weather is extremely complex, and so we're looking at the skew T. The red line is temperature, The green line is the moisture in the atmosphere. This blue line right here, that's the freeze line. So that'll come into play for winter. But notice the red and green lines are very close together, all the way up to 500 millibars, which is close to 3 miles or so. And so this sounding would indicate that we have a good rain chance, and yet it didn't happen. Some of that probably has to do with surface dryness and some other factors, but the fact is, there was nothing that indicated that this particular rain event was going to fail, and yet it ended up being half of what we expected. So, with something this simple, you can still get a failure with a seemingly good setup. That'll be even worse in the wintertime, because in the wintertime, not only are you looking at this, but then we end up with right in this area here, about 1,000 to 1,500 foot thick layer will be the dendritic growth zone, which is where snowflakes are created. And I don't think people realize snowflakes are created in such a small area, but they are. So then, you need a good DGZ, and then you need all below there. You don't want to get any dry slots like how this nudges off to the left up here above. You don't want to see that down here, because that means that you got dry air between where the snowflakes would form and the surface, so it'll evaporate. You also don't want to see the red line, veering off to the right of the blue line any, because then that means that you've got warm air advecting into it, and that turns you into either rain or sleet or freezing rain, depending on the conditions. So there's a lot that goes into forecasting all this, and I mean, that's just for a single short snapshot, let alone an entire season. So seasonal forecasting is really just a crapshoot, and really it's just for fun and to get an idea of what might happen. One of the other things we'll deal with is this is just a short list of the main atmospheric and oceanic oscillations that affect our winter weather, and really affect our weather all year long. But in this case, we're talking about winter. And there's, I think I've got 9 of them on here, but they're literally oscillations by the dozens that affect our weather. And the most prominent of which is ENSO, or El Nino Southern Oscillation. That's where we get our El Ninos and La Nina. And that's generally the dominant one, but not always. Second up is, through that same zone. By the way, ENSO is around the equator. I'll show you that in a few minutes. But the Madden-Julian Oscillation is our waves of storminess that travel along that same equatorial zone. For us, in the wintertime, most of the time, there are 8 phases to the Madden-Julian Oscillation, which the phases just refer to certain areas of the equator that the storminess is passing through. For us, generally, phases 8, 1, and 2 are the best for us to get cold and snow, but sometimes that falls through if any of these other drivers don't cooperate, or if the MJO is just simply weak. We've also got you'll hear us talk about the EPO, or the Alaskan Ridge. It's a ridge of high pressure that can set up in the Gulf of Alaska, either high or low. What we want for winter time is a negative EPO, which would give us a ridge over the Gulf of Alaska, and we really usually want it to be kind of close to the Canadian West Coast. That allows storms and cold air to go up and over, pick up cold air from the Arctic, and then drop into the central U.S. Another thing that I'm going to show you here in a little bit, probably to me has the most impact as far as long-term oscillations, is the PDO. And even at that, it doesn't tend to function the way, for us anyway, it doesn't tend to function the way you'll read in most texts or whatever. Most of them, you think that we would want a positive PDO for the wintertime, but I'll show you here in a little bit that it really doesn't matter whether it's positive or negative. It's really when we're in transition that helps. The PNA is just another West Coast ridge that's farther south than where the PDO or EPO would set up. It's usually a high pressure or low pressure off of the west coast of the United States, or just into the west coast of the United States. If the PDO is positive, or not PDO, the PNA is positive, it allows storms to go up and over. I'll kind of address it when I get to the La Nina slide, but it allows storms to go up and over and have a better chance of picking up some cooler air, but it brings in, that jet stream will usually bring in the moisture that'll work for our snowstorms. So generally we want a positive PNA, I should say. The Arctic Oscillation, or AO, is just what you would think. It's the conditions over the Arctic. You know, if there's a high pressure over the Arctic, last year it was really strong. That's a positive AO, and that means the cold air is going to stay bottled up north, and we've got almost no chance of getting Arctic air. That said, we don't really need Arctic air. We just need Canadian air. But the Arctic air is where we get our big cold blasts and some of our bigger snowstorms. You'll hear some people really get hung on the North Atlantic Oscillation, or the NAO. Again, we want to, that's also called the Greenland Block, and generally that's what we would want to see. It's a good thing to have, but it's not necessary. What the Greenland Block does is trap storm systems and cold air, and it basically will lock in a colder pattern. Instead of it being transient where we're going warm, cold, it'll just generally keep it cold and help us to get more frequent snow events. That said, the 2013-2014 snow season, which was our biggest snow season ever, we had no Greenland Block, but instead we had a big low pressure sitting over the Hudson Bay that just kept spinning the storms back through our area repeatedly. So we only had a couple of big snows that winter, but we had a lot of clippers. So the NAO is helpful, but it's not necessary. Polar vortex, we've all heard of that the last few years. It's been around forever. It's just the news has latched onto it and made it a big deal ever since that 2013-14 winter. The polar vortex kind of goes hand in hand with the Arctic Oscillation. If it's strong like it was last winter I believe it may have been record strong, but that keeps the cold air bottled up in the Arctic, and the chances of us getting any kind of an Arctic blast are slim to none. But if it gets weak, then some lobes of the polar vortex, if we get the right kind of disturbance or a sudden stratospheric warming event, that can dislodge cold air and give us a chance to get some stronger cold shots. And there are a couple others that factor in quite a bit. QBO, it's an oscillation that just is a shift between easterly and westerlies in the, I believe in the stratosphere. I try not to get too much into that. I don't think that it has a huge impact on our weather, other than it seems like in years where the QBO is descending or falling, we have a better shot, or if it's strongly negative, usually we have a better shot, although we've had a couple of winters where that didn't play out. And for instance, we had a big winter in 83-84. The QBO was strong all winter long, and we had a big snow season. But 78-79 was a top 10 snow season. It was positive all winter long. 12-13, it was negative all winter long, so that played out. So it's just kind of, to me, there's not a really good correlation on the QBO, but it's worth noting. Atmospheric angular momentum is also another oscillation. Here I am 15 minutes in this video, and I'm just covering oscillations. That should tell you how complex this stuff gets, and you're getting a very Cliff Note version. The atmospheric angular momentum is basically whether storm systems and the atmospheric winds are able to travel quickly or not. The more strong westerly in a positive phase, it acts more like El Nino. They're a little more easterly influence and slower in its negative phase, and that gives us a more La Nina effect, and that's kind of where we are now. That said, our friends at BAM really will break that down sometimes, and the AAM, it's different speeds at different latitudes, so really we need to look mostly at our mid-latitudes to see how it's, the storminess is going to be affecting us. And again, this is just like maybe 9 or 10. There are literally dozens of oscillations. I didn't even talk about the SOI or the Indian Ocean Dipole or the Antarctic Oscillation, any of that stuff. I mean, it's insane the amount of oscillations there are to try to keep track of, any one of which makes a sudden change and it can throw a wrench into everything, or it can make things be awesome. Sometimes that happens by surprise. So here's a typical La Nina. That said, there's no such thing as typical La Nina, typical El Nino. There's no such thing as normal temperatures or normal climate. It's just, we got to phrase it somehow. So generally speaking, this is what you expect to see during a La Nina. Right here is your strong EPO, or your negative EPO. It's your big blocking high pressure here. It forces your polar jet way up into northern Alaska, where it can pick up cold air and then drop it down the east side of the Rocky Mountains and into our area. Then you get your Pacific jet that, again, you can see the hump that's in it. Your PNA, positive PNA would be right here. If the PNA is negative, this jet's going to drop underneath. And a lot of times when that happens, that's when we get the big wintertime rainstorms or ice storms. So we generally want positive PNA, negative EPO. And that leads to wet in our area, generally leads to wet in our area for the winter, but also kind of leads to some warmer risks as well, kind of transient warmth, and that's what I would expect. But I think there's some other factors at play this winter, it seems like, that La Nina can be good for us, but sometimes it's not so great. I'll get into that here in a little bit too. There tend to be more warm risks. That said, the reason they're warm risks also is because there tends to be a stronger southeast ridge. I know you've heard me talk about that before, but so far the last month or two, that southeast ridge, when it's shown up, has been more flattened out on the northern side. So it's not really been pumping way up into our area. So that could be good if that would hold up. But if it would decide to get stronger, where it's really bubbling up closer to the Ohio River, again, that throws a wrench into a lot of things. Here are the Nino regions. And right here's the equator. So, there's regions. 1 is down here at the bottom, 2 is at the top of this little box. Nino 3 is the red, Nino 4 is the blue. But you see there's this Nino 3.4, and this is really where our winter weather can be affected the most from, when the MJO passes through it, and when the waters are, in my opinion, they need to be kind of neutral. They need to be slightly El Nino or slightly La Nina, but not enough to actually be classified as either one. It's technically neutral. Or what may be trying to set up this year, which would be a Modoki and El Nino or La Nina, where it's kind of a mix. There's a battle zone between the warm and cold, and that leads to some extra storminess, and that can help us out. That can help get the subtropical jet a little more juice to bring into our area. So we'll be watching Nino 3.4 to see how things play out there. And that Nino 3.4 right here is Hawaii. So this is kind of the areas along the equator to the south and southeast of Hawaii that we'd want to watch. These are actual sea surface temperatures. And the main thing I just want to show you here is, because when I get to the anomaly maps, this is all going to be blue. And so then, naturally you see it and you think it's cold. But these are still pretty warm temperatures. Right here off of the west coast of South America, the temperatures are, water temperatures probably in the lower 60s. So that's pretty cold. And you can kind of see the nose where the easterly winds are kind of blowing and forcing this cooler water to the west. And But by the time you're getting out here, the water temperatures are in the 70s. By the time you're out in here, they're in the 80s. And, it's in the mid to upper 80s by the Western Pacific. So, when you see the blues on there, the cold it's all relative. Same way when you'll see there are going to be a bunch of reds up here in the Arctic Ocean. But really, I mean, this is all right here freezing and below. Now it is well above freezing here, probably in the lower 40s out here north of Russia. So, and that can have an effect on our weather. So we'll have to see how that develops. But I just wanted to show you absolute temperatures so that this doesn't fool the eye too much, because there are your cools, where the La Nina, the cooler water is being forced to the west. Here's rough. My 3.4 circle is actually too far west. It probably should be more over here. But again, it's just kind of a current look at the state of things. Right now, we've got warm waters where the PDO and EPO would be. But you'll see in a minute the trends have been cooler here recently. We seem to be in a transition from a positive PDO to a negative PDO. We really would want to see that happen in another month or so instead of now. So we'll see if that messes with us, or maybe the trend will stop. And by the same token, we'd rather see this out here warming up. I mean, cooling down. We'd rather see a low out here in this circle and a high pressure in this circle. And it's trying to set up the exact opposite right now. Got some cooling waters off of the East Coast. Pretty warm waters down here. We want to see the warmer waters here. A lot of this cool water off the East Coast may be due to tropical. You can almost see the little curve here. I think the tropical storms have had an effect on that, and it's possible they may start to warm back up a little bit in the aftermath. Again, we kind of want a southeast ridge, but we don't want it to be too strong. So hopefully this doesn't get too warm. Usually in the Atlantic, what you want to see is kind of a warm, cold, warm, cold, warm kind of thing. And it's trying to set that up a little bit. So we'll see how it goes. We want to see this warm up here, because that can help build up that negative NAO that I talked about earlier. These are the trends over the last 7 days. And you see in that NAO area, it's been cooling down over the last 7 days. This has cooled down, but again, they've had tropical, had a lot of storm activity off of the coast, so that's had an effect there. There's that PDO and EPO region cooling down over the last 7 days, and the Aleutian Islands warming up. Again, we don't really want to see that. So hopefully it's just a short-term trend, but there'll be the kind of things that we're going to be monitoring to try to figure out where things are heading for the winter before we make a forecast. And in this circle here, you can kind of see the 3.4 region of the Nina region here. And you can see there's kind of warm interspersed with cold. And so that's where I'm wondering if there's not getting ready to be a little bit of a battle zone right there. And where we kind of end up in more of a Modoki La Nina or El Nino type of situation that can actually help us out and maybe help override some of the other factors that are going on. I like it being right there because it can create kind of what's like a standing wave. If we can keep the easterlies and they fade out right in this area, then you can keep your MJO pulses coming and get them to die out and stall right where we would want them. If you want cold and if you want snow, maybe we can get those pulses to die out right there. Last winter, there was an easterly wave as this La Nina was first, showing signs of building, and it stalled out just a little bit too west. So that's why the Great Plains kept getting hammered in Minnesota and all that, and we just couldn't get anything here. We were missing by 300 miles just because of where those pulses were dying off. So hopefully this right here will continue and be more of a Modoki setup, and where we can kill the pulses off or stall them right in here and help us out with some snow. Again, this is all just kind of what we're watching. Another thing to watch is Arctic sea ice. I'm not wholly convinced on how much of an effect this has by the time we get to winter, other than but this on the left is our current Arctic sea ice extent. The one on the right overlays our current sea ice extent with the 2012, because this year was almost melted down. 2012 is the lowest on record since in the satellite era since 1979. So this year is the second lowest. And but you know, that's okay, I was making sure I was looking at the right thing. But again, you know, people would like to point at the Arctic sea ice thing as being a thing that's going to hamper our winter because of warm waters here. But one, it's already starting to freeze. As I showed you, the temperatures in the Arctic Ocean are already below freezing up here north of Alaska. Now, they're warm on this other side, but they're cold here, and that actually can help if we can get some storms coming with some moisture load up and over into the cold air and dropping in. That could help us out. But I would point back to the 2012, 2013 snow season. You know, right after this record low Arctic sea ice extent in 2012, we had one of our bigger snow winters. So I'm just not convinced that the Arctic sea ice affects our winter that much. I think some of it depends on where the warm waters are. I think if the warm waters were all along the north coast of Canada, and the low sea ice was along the north coast of Canada and north of Alaska, then it would have more of an effect than what it's probably going to have. To me, the big driver is the PDO. It seems that it turns up very well. In looking back at our bigger winters, all of our top 10 snowiest winters have been since 1973. And so as we're looking at the PDO, of course the blues are negative PDO and the reds are positive PDO. And I've broken it down up here. Our big winters with the PDO going from negative to positive, which is usually what we would want to see. That's where a lot of our biggest winters have come. Including that 2013-14 season, we were in transition from negative to positive. At 2009 and 10, it was doing it, and there was even an El Nino at play, and we still had 35 inches of snow that winter. 73-74 was a Modoki La Nina year, and we had a big, almost 40 inches of snow that winter. By the way, the numbers, I don't know how well you're going to be able to see it on this video, but the numbers with asterisks by them, those are numbers from Anderson, where there was a complete enough record for the winter to be able to use numbers from Anderson instead of Indianapolis. Big winters where the PDO was going from positive to negative. That's more where we're going to fall this year, and hopefully that transition really stalls maybe another month or so before it begins to really transition negative. 1981-82, our second biggest snow year, 51 inches that winter, and we were in transition from going from positive to negative. 83-84, it happened with a Modoki La Nina going on, 39.3. So that can be a good, where we're at could be a good thing with the PDO if the PDO's cooling slows just a little bit for us. Winter with the PDO negative all winter long, that's supposed to be a bad thing. The low Arctic sea ice is supposed to be a bad thing, and yet here we had 35.2 inches of snow in Anderson in that 2012-13 winter. So that just goes to show that these drivers only tell you so much, but there's a pretty strong indication with the PDO that you just don't, to me, you don't get with anybody else. Bad winters, we only had one bad winter. To me, what I classified as a bad winter was, less than 12 inches of snow. We had one, the 1972-73 winter, only 4.5 inches, but it happened during a strong El Nino. Bad winters with the positive PDO. Again, we had 3 of them, but 2 of them happened during strong El Ninos, 2 of the strongest El Ninos, as a matter of fact. 16-17 happened with a Modoki La Nina going on, but it was in between, and we're starting to transition back to a La Nina, or to an El Nino. So the waters didn't really cool that much in that 16-17 winter, and that may have been why we had such a stinky snow season with only 6 inches of snow. So this kind of, to me, the main thing I'm watching are the North Pacific waters and the Nino 3.4. Those are the main things I'm watching to see how they develop over the next month or so. That's going to give us a good indication of where this winter is heading. This is the Climate Prediction Center's forecast for the winter. And if you remember back to the La Nina, typical La Nina map, this pretty much follows what the typical La Nina is. I think their temperature thing is probably going to pan out pretty well. They've got our area in equal chances of being either warm or cool. As I indicated earlier, I think we're going to be up and down, and we may start off cool in November, early December. Hopefully we don't warm up too much in December, but at the pace the pattern's on, that's probably what's going to happen. Doesn't mean it'll warm up so much that we're not going to have any snow, but just snow is going to be a little harder to come by, I think, probably in late December and through part of January. It's still a long way out, though, so that could be totally wrong. They also have us well above normal precipitation, or not well above, just above average. Chance of being above on precipitation. That could happen. I have a feeling we're going to be a little drier than what is in a typical La Nina. And a lot of times when you see above normal precipitation in the winter, that's usually falls in the form of rain. We have had a couple of big winters that were really wet also, but a lot of them were around average or maybe even a little below average on actual liquid precipitation. But that's because we have cold air at play, and that cold air, while it keeps the heavy precipitation away, it also tends to squeeze every drop of precipitation out when snowmakers come, so it fluffs up good, and you actually end up with bigger snows with less liquid content a lot of times. These are just the composites of what normally happens is from the CPC, and normally December through February we're running a little bit above, half a degree or so above average on temperatures. Not too bad. It's a good sign that it's probably a battleground. Run a little bit above average on rain, and we run typically about average, or maybe there's a little bit of blue getting into here, maybe 1 to 3 inches above average on snow. That's from CPC, and that's just what's common for a typical La Nina. And notice down here at the bottom are years that they used since 1950. We've had 2 bad winters in the La Nina years, and 4, 5, 6 really good winters and during La Nina years. So our odds are better for a good winter than a bad. Here's what the CFS V2, which is an American model, a seasonal model. It's got us torched. It's got us 3 degrees above average in December. It's got us running, 1.5 above average in January, and then has us running about 0.5 degree above average in February. I don't think December is going to torch that bad. I think it's going to start off probably cool and then start warming up. I think if one of these 3 months is going to so-called torch, it would maybe be January. And even at that, 3 degrees above average, in the heart of January, the average high temperature is 34 degrees. So you're looking at 37 degrees. So, and what that really means is probably a lot of days in the 40s and a lot of days in the 20s. And when we're in the interchange between the two is where we're going to have snow chances. So just because there's a lot of red on any given month doesn't mean it's just going to be Bahama shorts all winter long. I do agree with this. Probably, the February temperatures probably look pretty good. I don't think we're going to have a backloaded winter like we have the last few, where we start off, we're kind of cool in November, get a little bit of snow in November, and then it's warm until February, and then we end up cold in March and April. I don't think that's going to happen this year. I think we're going to start off with some snow, get warm in the middle, and then cool back off in February. And I think our transition into spring will probably be pretty on time. Just speculation from this far out. So this video got a lot longer than I planned on it being. We're at about 35 minutes, so I'm going to cut it off there. But that's just kind of what I'm looking for over the next month or so. Right now I'm inclined to think that it's going to be a very mixed bag winter. I think we're going to have a better chance of getting a couple of bigger snows than what we've had the last couple of years. But I also think that we're going to have a better chance of getting some ice than we've, we did have a big ice storm last November, but or November of 18. But ice storms may be a little more of a threat, especially during January. But we'll see how that all plays out. But if I had to throw something out there right now, I think we're going to be, our average snowfall for the winter for Anderson is 18 inches, which back in the 80s it was like 24 inches. So we've lost a lot over the last 3 years, or last 30 years. Even though we've had a couple of our biggest winters, we've also had some of our biggest stinkers over that period. But I would, if I had to guess right now, I think we're going to be in the mid-20s on snow. Maybe we get lucky and get a big snowstorm in there somewhere. But and I think our temperatures are going to run slightly above average over the 3-month period. But we'll see how these sea surface temperatures and oscillations and all that build up over the next month or so. Like I said, by the time we get to the end of October, it should be showing its face pretty well. And we might have a better idea where we can actually put some numbers on a map. Do a shorter, maybe less boring video. So that's where I'm going to wrap this up. And hopefully we'll see you all on the website. We'll start getting some good content there for you, and start building something awesome. And in the meantime, you all have a great night, a great week, and I will put a forecast out shortly. Thank you.